All right, welcome back to Mr. Newbold's video. Yeah, so go ahead and say hi, everybody. Say hi, 3, 2, 1. Yeah, there we go. All right, we love our flex class. Okay, bring it down, We love our flex class. We do love flex class. So we learned some rules in class about finding the vertical asymptote. And from Nancy, that's right. So Nancy helped with the horizontal asymptote. So the vertical asymptote is basically just like the exceptions, right? The exceptions where you set the bottom equal to 0. So and that's exactly what it is. And then solve for x. Now the horizontal asymptote has 3 rules to it. So it's if the top degree is less than the bottom degree, then the horizontal asymptote is just y equals 0. If the top degree is equal to the bottom degree, then it's just the leading coefficients in front of those x squareds or x cubes or x to the first power. Yeah, it's a 1 over 3. So in other words, 1/3. And then if the degree is greater than the bottom degree, then you can say none if you want to, because there is no horizontal asymptote. Or you can call it slanted. Or there's another word. Oblique is another word. Yeah, oblique, which is another word just like slanted. I think in 1050, 1060, they use the word oblique instead of slanted. Okay, so I have a request from Tay for number 5. Is it number 6? Okay, so do number 6. Okay, so number 6, let's take a look at number 6. So 5 and 6. Okay, so 5 and 6. So first of all, to find the vertical asymptote, we just set x squared equal to 0 and just solve for x. So then we go ahead and to solve for x, we just go ahead and square root both sides. So square root both sides like that. So we get x equals 0. And you can say plus or minus 0, but it's still 0. And so then that is our vertical asymptote, just 0. So our vertical asymptote is just x equals 0. If you're going to graph this sucker, which eventually we will do, x equals 0 is a vertical asymptote. It's a line that goes along the y-axis, just like that. It's just an invisible barrier is what an asymptote is, right? That the graph doesn't touch. It gets really close to it, but it doesn't actually cross it. It just gets really close to it. Now the horizontal asymptote, we got to look at our rules, Nancy's rules. Hope she doesn't find this video. She'll be like, how did they know my video name? Oh, anyways, she's a girl from MIT that helped us understand horizontal asymptotes. Yeah, had to be there. Okay, so it's the powers. So what do you guys think? Do they have the same powers? Or do they have one greater than the other? So is 2 equal to 2? So since 2 is equal to 2, right? X squared is equal to x squared. We're actually going to use the numbers that are in front. And so they're invisible. What number is in front of x squared?
1.
Just a 1, invisible 1. And so it's the top over the bottom. So then it's just going to be y is equal to 1 over 1, or just 1. And so the horizontal asymptote is just y equals 1. Now to try to help you really understand this a little bit better there, if you remember from class, if I didn't already do it with you, number 2 is or number 4, let me see. Number 4 is a really good example of a horizontal asymptote. Ha, 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 ha. So it's a horizontal asymptote where we do have a different number other than 1. We have a 4 in front of that x squared. Powers are the same. So we're just going to use 4 over 1. So the horizontal asymptote is just 4 over 1. Not too bad on number 4, right? So what would the vertical asymptote be? So the vertical asymptote is where you set the bottom equal to 0, right? So we're going to go x squared minus 1 equals 0. So we're going to set the bottom equal to, why is it doing that? Set the bottom equal to 0. Okay, so then how do we solve for x there? Add 1, good. Add 1 to the other side. So now we have x squared is equal to 1. And then square root both sides, right? Yeah, then square root both sides. And when you square root both sides, you get x equals plus or minus 1. Another way you've done it is you could have factored this sucker, right? And get x and x, 1 and 1. One's plus and one's minus. because it's a special difference of squares. Special difference of squares factoring. And you still would have got plus or minus 1, right? A positive 1 and a negative 1. Now, there is a trick to this as well, though. These are the simple ones for finding the vertical and the horizontal asymptotes. Number 3 is pretty easy. Set equals 0, bias 3 to both sides. So we just get x equals negative 3 for the vertical asymptote. So just set the bottom 0, solve for x. Now, the ones that are tricky, is going to be something where, let's see here, like number 6. So the powers are the same, but we do have a negative there. So then our horizontal asymptote is just y equals negative 1, or negative 1 over 1. Cool. So to finish this video, I'm going to keep on going. Have a good day, you guys. Excellent work in Flex today. Thanks for working hard. Yeah, thank you. So we do intense ones, right? What do you mean by intense? I mean, some of these are not vertical asymptotes, they're holes. What do you mean? If it cancels in the bottom and the top, it's a hole. And we'll do more of that today in class, but we'll show on the video right now. So for example, let's take a look at, let's see, which one has a hole in it? Probably the other side. Yeah, take a look at number 13. That's a wicked evil one. Thanks. Peace. Have a good one. Okay, so take a look at number 13. Did you guys know what 13 is really crazy? Because 13, still doing the video. So number 13 has, thank you. So number 13 is actually difference of cubes. Uh-oh. Do you guys remember that formula, difference of cubes? So the difference of cubes formula is a minus b times a squared plus a times b plus b squared. So that's what this x cubed minus 1 factors into. Why do I thought you just factor the bottom and set it equals 0, Diebold? Well, sometimes the top and the bottom are factorable and can cancel out. And that is going to add a little twist to our problem. So first we'll do this bottom one. This one's pretty easy. You guys remember single factoring? Oh, single ladies. Oh, single ladies. What do they both have in common? So we're going to divide by x, multiply by x. Like that. That's called single factoring. Remember that? You'll need to do that on the test coming up. So x squared divided by x, right? So there's 2 of them up here, because that's what x squared means. And so one of them is going to cancel, just leaving us with an x. And then x over x just is a 1, right? Anything divided by itself is just 1. So x squared minus x factors into x times x minus 1. It's single factoring because that's just by itself. That x is just by itself. It is still 2 parentheses factoring, but it's single factoring because there's only one x there. There's no number next to it or anything like that. Okay, so then we got to do this guy. And so this is the difference of cubes in number 13. And so cubed minus 1. So the x cubed factors into x times x times x. The 1 factors into 1 times 1 times 1 because it's a cubes, right? The cubes. And so that means that a is going to equal x. So wherever you see an a, you're going to put an x. Wherever you see a b, you're just going to put a 1 because just x and 1 is what we're going to be using. So then this is going to be x squared plus a is x again, and b is just a 1. And then plus b squared is just 1 squared, which is just 1. Now the reason why I wanted to factor this sucker right here is because now you can actually cancel the top and the bottom. Why would you even need to do that? Well, because when finding a vertical asymptote, what do you do again? Do you guys remember? Finding a vertical asymptote, you set the what? The bottom equal to 0. Good. And so when we set the bottom equal to 0, we were going to get vertical asymptotes at x equals 0 and at x equals add 1 to both sides. At x equals positive 1, right? X equals positive 1, yep. So we were going to get 2 vertical asymptotes. But since the top, x minus 1, cancels with the bottom, x minus 1, that is actually a hole, not an asymptote. So the only vertical asymptote for number 13 is x equals 0. Is the only vertical asymptote for number 13. Now the horizontal asymptote, we have top is less than bottom. And since the top, right, and we'll do this again in class, don't worry. So since the top is since the top is greater than the bottom, then for the horizontal asymptote, you would just say that y is equal to none. There is no horizontal asymptote. And the reason why is it's actually a slanted asymptote. We'll teach you all this again because we only barely went over it just before break. So we'll do this whole lesson today, don't you worry. So that would be none. If for extra credit, give me 2 seconds because we're making a video right now. So give me 2 seconds. So for extra credit, you can actually find what that slanted horizontal asymptote is. And how you find that slanted asymptote is you do long division, x squared minus x into x cubed minus 1, right? You do long division, that'll actually give you the slanted asymptote equation. So I'll continue on this video and do a second video for you, but trying to get this video fixed from last time. So definitely thanks for watching and tune in on the next one when we get that one done too. Peace out for now. Say goodbye, everybody.
Goodbye.
Yeah. Immortalized forever.